Before I can get you started to learn about bonding and structure, it is first important for me to build a foundation on ions because ions are rather important. And this lesson is going to explain what ions are. Okay, we're going to define ions. And we're also going to talk about why they are formed. And as well as I'm going to tell you how to predict the charges on some simple ones for your GCSE. Okay, and immediately you are able to do all of this, I'll tell you you're ready to learn about anything under bonding and the structure of different atoms. Now, let's get started. What are ions? Well, let me assume this is not the first time you are hearing the word ions. So, you will, if you are not hearing it for the first time, it means you would have a kind of definition or what you think about it. But a simple way to define ions is to just say that they are charged particles. Ions are charged particles. Ions are charged particles. Now, let's break it down a little bit. When we talk about charges, either in physics or chemistry, we are only talking about two things. We're talking about the positive charge, and of course you can say the second one, which is the negative charge. So these are the two major charges that we talk about when we talk about charges. So, and this is represented with the plus sign and this with the minus sign. So again, we say ions are charged particles. That is, they are charged particles. It means they can either be positive or negative. Now, with that being said, another thing to note is that ions can be for a single atom. Okay, when I say single atom, ions can be for single atoms, and single atoms like chloride ion, okay, like sodium ion, like oxygen ion, and then let me just write one more, magnesium ion. Now, all of these are single atom because this is just an element, right? And the charge, the negative charge you have here is just for chlorine. The positive charge you have here just belongs to sodium. The negative 2 you have here belongs to oxygen. The positive 2 we have here belongs to magnesium. And it could also be about group of atoms. And when I say group of atoms, what am I talking about? We're talking about something like this. When you have NO3 minus, in this case, the charge, the minus, the negative charge you are seeing here is not just for chlorine, it's not just for nitrogen, it's for the both of them. So it is a group of atom, that is NO3 owns the negative charge. The negative charge belongs to them. So ions is not just for a single atom like you have here, or I can show you another kind of group of atom when we talk about the hydroxyl ion. Here you have oxygen and hydrogen, which we call the hydroxyl, and there is this negative charge. Now, in chemistry, please note, in chemistry, if you see some two elements written together this way, and you have a negative sign on top this way. The negative sign is not just for hydrogen, it's for both elements, right? It's for both elements. Now, please, I will just say this in case you have struggled with how to represent elements in the past. When we represent elements, like in this case of magnesium, you see that it is capital letter M with a small letter G. This is a single element, okay? You see the same thing goes with sodium, capital letter N with small letter A, that is sodium, is a single element. However, if it is two elements, it will be capital letters. Like in this case, you see nitrogen and oxygen, both are capital letters. So it's good for you to keep that in mind. Now, don't forget what we have learned so far. We have learned that ions are charged particles. Okay, they are charged particles, and we have identified the different charges which can be positive or negative charge. And we have also said that ions can be for single atoms or for groups of atoms, right? So that helps us to be able to give some definition to what ions are. Now, another thing for you to keep in mind is ions are formed when electrons are lost or gained. Now, let me pause a little bit here to explain some more details about the structure of an atom. Remember that in the structure of an atom, we have three major, or let me say fundamentally, we have three basic subatomic particles. And the subatomic particles are protons, okay, protons, neutron, and electrons. Now, these are the three major subatomic particles. Two of the subatomic particles, that is the proton and the neutron, can be found in the nucleus of the atom. Proton and neutron can be found in the nucleus of the atom, while electrons, we say they are in orbit around the atom. That is they are moving in orbit, something like in a spherical, in a sphere. They are moving in a spherical direction around the atom. So they're just going, like, if you like, we can say something around like a circular direction. So they're moving like that. That is electrons. And electrons are in different energy levels. So don't forget, these three major subatomic particles are protons, neutrons, and electrons. And we have said that the proton and the neutrons, they are in the nucleus of the atom, while the electrons are moving in orbit around the atoms. Now, what should you know about the electrons? The electrons are the ones that determines the chemical properties of an element. Let me stop there. As we go on further, you're going to know more about the electrons. Now, keep in mind, the proton is positively charged. Okay? Neutron has no charge. And the electron is negatively charged. It's negatively charged. Electron is negatively charged. Proton is positively charged. Now, if we say an atom is neutral, whenever you hear that something is neutral, it means that the protons, the number of protons is equal to the number of electrons. So another way to say it is the number of positive charge, the number of positive charge is the same thing as the number of negative charges. So if the number of positive charges is equal to the number of negative charges, the atom will be neutral. And if the number of protons, so if the number of protons is more than the number of neutrons, you see, the atom is no longer neutral. The same thing goes for the electron. If the electron is more than the number of protons, the atom is also no longer neutral. Now, if you understand this, I'm so happy. So I can make the next statement again, that metals, right? Metals lose electrons. Metals lose electrons. Don't forget that. Metals, what do? Metals lose electrons. And the non-metals, what would they do? If one is losing, non-metal will gain electrons. So now you see that our focus is on the electrons and not the protons or the neutrons at this time. Our focus is just on the electrons. So metals will readily lose electrons. Now, I can see you start to wonder, or you may start to quickly think, what are the examples of metal? I know the easiest one for you to think about will be to think about ions, copper, zinc, aluminum. Yeah, they are also types of metals. However, in this lesson, we're going to start with the major types of metals that we talk about in chemistry, which are the group 1, like sodium. I'm using the symbols of the elements so that you can get used to identifying elements by their symbols. Sodium, lithium, potassium, right? And all of these are group 1 elements. We're going to see that later. You can also have magnesium, and all of these are examples of metals. So if you have sodium, if you have lithium, if you have potassium, if you have magnesium, all of these metals will lose electrons. Do you see that? Now, what about non-metals? If you have elements like chlorine, oxygen, let's also say fluorine, bromine, all of these are non-metals and they will gain electrons. So now, if an element loses electron, remember where we started from over here. If the number of protons is the same thing as the number of electrons, right? It means that the atom will be neutral. Now, you can imagine an element has 11 protons and also 11 electrons. So we say this element is neutral, or this atom is neutral. Why? Because the number of protons is the same thing as the number of electrons. Now, if this atom loses 1 electron, out of the 11 electrons, it lost 1 electron. Now, there will be 10 electrons left, and then you have 11 electrons, 11 protons here. So you see that it is no longer balanced. The number of protons is now greater than the number of electrons. So since the proton is more than the electron by 1, the element will have a positive charge. So this is why we now say that when metals lose electrons, they become positively charged. So think about the next thing. If I have 17 protons and 17 electrons, we say this element is neutral. Now, if I had an extra electron to this 17 and then I have 18 electrons, what do you see? You now see that the number of protons is smaller or lesser than the number of electrons. So you have more electrons and you have one more electron. And remember, electrons are negatively charged. So when a non-metal gains electrons, they become negatively charged. Negatively charged. And when a metal loses electrons, they become positively charged. So don't forget what we are still looking at. We have looked at the definition of ions. We say they are charged particles. And we have looked at the different types of charges, which can be just positive and negative charge. We have also looked at it that single atoms can form ions and group of atoms can form ions. Now, we have also said that ions are formed when elements lose or gain electrons. And then we went on to look at the three subatomic particles, which are the protons, neutrons, and electrons. We said the proton is positively charged, the electron is negatively charged, and we have also said that if the number of protons is equal to the number of electrons, the atom will be neutral. If there is a difference in any of these, then the atom is no longer neutral. And now we said that if a metal loses electron, it becomes positively charged. Why? Because there will be more protons than electrons. And we've also said that if a non-metal gains electron, it will become negatively charged. Why? Because there will be more electrons than protons. Now, I'm so glad if you have an understanding of what we have done so far. Now, the next thing is going to be for us to see some different examples of how these ions, how elements form ions, how do they lose their electrons and the likes of it. Now, here is the periodic table. And we are not learning about the periodic table right now. However, it's good for me to show you some things about the periodic table. It's going to go a long way in boosting your knowledge about bonding and especially about what we are learning about right now, learning about ions. Now, when you look at the situation with bonding, we call this part here on the left hand side is where we have the metals, and here is group 1, right? So the elements you can see here, right, from lithium to sodium to potassium to rubidium to cesium to francesium, they are group 1 element, apart from hydrogen. Hydrogen is not a group 1 element. Then group 2 are beryllium, magnesium, calcium, barium, and then radon. Now, all of these elements, the elements here, we call them group 2 metals. This one are group 1 metals from lithium downward. Now, on the other hand, we are not talking about the ones at the center right now. So now here again, if we leave all of these and then I come to group 7, because that's group 2, then you come here, this is group 3, group 4, group 5, group 6, group 7, and we call this the group 8 or group 0. Okay, so the group 4 elements, don't bother yourself about them. Group 4 elements don't form ions. They don't form ions. They will not lose or they will form bonding, but they will not lose or gain electron, as it were. So group 4, they are not involved in what we are talking about. Well, our focus will not majorly be around group 5 as such. They are not really very reactive, but our focus will be with group 6 and group 7. Okay, group 6 and group 7. Now, again, I said we are not learning about the periodic table. So in another lesson, I can talk about the reason why these are when I am teaching you about the periodic table. But for now, we just want to focus about the ions. So now we're going to go back again. Group 1 elements are lithium, sodium, potassium, rubidium, cesium, francium. And then group 2, you have beryllium, magnesium, calcium, on and on. And then we'll come to group 6, which are the non-metals. Group 6, group 7, they are non-metals. In fact, apart from, we try to draw a line that shows like you're doing your staircase around. Okay. Now, apart from all of these elements from aluminum downward like that, every other element here are non-metals. But again, our focus is on group 6, where you have oxygen, and group 7, where you have fluorine, chlorine, bromine, iodine, and the likes of them. So why are we talking about this? When we say an element is in group 1, it means that the element has 1 electron in the outermost shell. If an element is in group 2, it means that the element has 2 electrons in the outermost shell. If an element is in group 3, it means that the element has 3 electrons in the outermost shell. Group 4, how many electrons? 4, good. Group 5, how many? 5, good. Group 6, on and on. Group 7 and group 0 or group 8 also have 8 electrons in the outermost shell. So now, another thing you have to pay attention to is, of course, in your GCSE, you will always be provided with a periodic table of the element. So you need not to really trouble yourself too much about remembering all of the elements. However, you have to know how to use it so that you will not be shocked or you will not be confused or make a mistake while using the periodic table. So you have to remember the atomic number of each of the elements. Now, when you look at the periodic table, mine is not too bold at this time, but if you have one, you always have one behind your science book. So you always have a periodic table behind. You can just have a look. Now, the symbol of the element is what you see. Then you see the name underlinked, and then you will see 2 numbers. It depends. Sometimes in some cases, you can see the numbers written this way. For example, let me use sodium. You see a number written underneath as a subscript, which is 11. And then you're seeing a number on top as 23. Now, the number below usually is the atomic number or the number of protons. Atomic number is the number of protons. So atomic number is the one you see underneath. And at other times, in some cases, you can see some periodic table where this will be swapped around. But the general convention is that you have the atomic number under here, and then what you have here is the mass number, is the mass number of the element, the mass number of the element. So underneath is the atomic number. So you need to have the knowledge of the atomic number for you to have a good understanding of what we are learning presently. So when you look at lithium, lithium has an atomic number of 3, sodium 11, potassium 19. You look at beryllium, beryllium is 4, magnesium is 12, calcium is 20. Now you go to group 6, oxygen is 8, sulfur is 18. You go to group 7, fluorine is 9, chlorine is 17, and then bromine is 35. So it goes on and on. we can look at all of that. Those are the atomic number. So you just have to, in this case, in the case of this periodic table, it has been said what they did. They said they have written the atomic number on top and the atomic weight or atomic mass below. So you see, you have to always follow that to check that. That's why I said if you are used to the periodic table, it becomes very easy for you to make use of it, and then you will not be making mistake. Now, so let's get back to now doing different examples of how elements lose electrons and gain electrons. So let's start again with our favorite element so far, that's sodium. If I want to represent sodium, okay, sodium, like I have been able to show you, has an atomic number of 11. Okay, so this is sodium with atomic number or number of proton, which is 11. And remember, we said sodium is going to be neutral at this time. Why? Because it has the same number of protons and neutrons. So if there is no charge written on an element, it means the element is neutral. And the implication, of course, is the number of protons is equal to the number of electrons. Now, but if we write the electronic structure for sodium, the smallest shell can take a maximum of 2 electrons. Subtract 2 from 11. How many electrons is left? 9. Good. So it's just like the shell of onions, right? So the smallest shell will take 2, and then the next shell will take maximum of 8. So you had 2 to 8, that's 10. So how many electrons is left? You have 1. So of course, the next shell too should take 8. After the first shell is the only shell that takes maximum of 2. The rest of it will take 8 afterwards. So, but here, because we only have 1 electron left, so we just leave it at that. That's 1 electron. Now, where are we going with this? I can also draw it by shell. This is sodium, okay? And the smallest shell, I said, will take maximum of 2 electrons. And then we can have the next shell. Next shell will take 8 electrons. We just always write these electrons in pairs just to make it easy, okay? And the third shell, because sodium only has 11 electrons. So the third shell is just going to have 1 electron. 1 electron. Now, during the process of forming ion, becoming an ion, sodium has to lose this electron. So when sodium loses this 1 electron, right, what will be the number of electrons left? It will be 10. So like I showed you earlier, remember at first sodium was neutral. It has 11 protons, and since it was neutral, it also have 11 electrons. Okay, now sodium loses 1 electron. After losing 1 electron, how many electrons will be left? So there will be 10 electrons. So the number of protons is no longer equal to the number of electrons. So sodium has become an ion. So we write it as Na+. The plus is to tell you that there are more protons than electrons. And it's saying again in a simple shell, in a simple word, is that sodium has lost 1 electron. So anytime you see a positive sign on any element, it means the element has lost an electron. And the only element in the periodic table that will lose electron are the metals. Only metals will lose electrons. only metals will lose electrons. Only metals will lose electrons and become positively charged. So if you look at the non-metals, let's look at chlorine. The atomic number for chlorine is 17. The mass number is 35.5. Okay, so chlorine as a neutral atom has the same number of proton to neutron. If we write the electronic structure, the smallest shell will take 2, subtract 2 from that, and then we can have another 8, right? Because there is still more. If you add 2 to 8, that's 10. 10 from 17, we still have 7 left. So the next shell can only take what is left, which is 7. Okay, so we have 2, 8, 7. Now, you see, in this case, chlorine will not lose 7 electrons, but it is able to gain an extra electron that is coming from sodium to be added to it. So again, if chlorine gets this extra electron added to it, you see now that it's going to be more electrons than proton. So again, chlorine will become negatively charged. And the negative charge also shows you that the element has gained an extra electron. If it is 2 electrons that the element has gained, like in the case of oxygen, if it is 2 electrons, you write it as -2. If the element loses 2 electrons, like in the case of magnesium, remember I said it earlier, magnesium is in group 2, and group 2 elements will be able to lose 2 electrons. So when they lose these 2 electrons, they are written as Mg2 plus to show that they lost 2 electrons. Okay, the same thing goes for calcium. It's going to be 2 plus. It has lost 2 electrons. So these are the ways in which we can look at how elements, how ions are formed. How ions are formed. Now that will bring us to the next question for us to answer. Why are ions formed? Why do elements form ions? They form ions because they want to be stable. Now, if you have a periodic table with you, you can look at the group 8 elements where you will see elements like helium. Helium has just 2 protons. Now, if you look at another element like neon, let me write the symbol, neon, and then we can have another element like argon. Okay, argon is 18. The atomic number for argon is 18. So you can see that we have argon. All of these elements are stable. Why? I told you that the smallest shell can take a maximum of 2 electrons, while the next shell after the smallest is going to be 888. So argon has the second shell filled up and filled up. So argon does not need an extra electron and does not need to lose any electron. It is stable. So we say that when atoms lose or gain electrons to form ions, all they are trying to do is to get a full outer shell like these noble gases. So you see an example when sodium, after sodium lost an electron, lost 1 electron, you see now sodium is having an electronic configuration of 2,8. 2,8 is now looking like that of neon. Okay, it's having an electronic structure that is looking like that of neon after losing 1 electron. So this is the way by which we look at it. For example, again, look at calcium. The number of protons in calcium, the number of electrons is going to be 2882. However, when calcium loses these 2 electrons, you see now that the electronic structure will look like that of argon. So the reason why elements form ion is because they want to have a full outer shell like a noble gas, or they want to have a stable electronic structure. So, and finally on this is for you to keep in mind that the group of the elements will tell you the number of electrons they can lose or gain. I've said that before. So group 1 elements will lose 1 electron, and therefore their charge will be positive because they are metals. Group 2 will lose 2 electrons, and the charge is also going to be positive, and they are metals. Now, when you go back to I've told you that group 4 do not form ions. So you can go to group 6 elements. They are non-metals, and they will gain 2 electrons, and that means their charge will be negative. The same thing go for group 7. They will gain 1 electron, and their charge will be negative. Group 7 do not gain or lose any electron. So I hope you have enjoyed this lesson on ions. Kindly let me hear back from you. Look forward to the questions that will come on your way on this topic, and I will see you in the next topic where we'll be talking about the ionic bonding. Now we'll start to look at ionic bonding. So if you have any question, just let me know by you leaving it in the comment section. Thank you very much. See you. Bye. Now that you've learned about ions, what they are, how they are formed, and how to predict the ionic charges of some simple elements or atoms, it's now a good time for you to learn about chemical bonding. Chemical bond involves the way that atoms interact together to form a compound. And we basically have 3 types of chemical bond. To say the strongest types of chemical bonds are 3 in number. The first one being ionic bonding. The next one is covalent bond. And the third one is metallic bonding. These are the 3 strong types of chemical bonds that we have. And in this lesson, you will be learning about the ionic bonding. And there are loads of things for you to learn about ionic bonding. You're going to learn about what ionic bonding is. And then you will also learn about how it works and how you can represent it, and also how you will be able to work out the formulas of an ionic compound. Now, so far from the previous lesson, you have seen that when atoms gain or lose electrons, we call them ions. That is, we said that ions are charged particles, which results from atoms losing or gaining electrons. And we said they do this because these atoms also want to become very stable, like the group 8 element or group 0 element. Now, let's crack it on. Let's talk about ionic bonding. In this case, what you have is we're going to be looking at a situation of metal reacting with metal. Again, let me help you to remember that we have talked about the major groups of metals that we will be looking at this moment. And they are the group 1 and group 2 metal. So group 1 and the group 2 metal. Now, for group 1 is where you have elements like lithium, elements like sodium, and here you have magnesium. And when we talk about the group 2 element, group 2 is where we have elements like beryllium, Be, elements like magnesium, and elements like calcium. Okay, there are more elements under these various groups, but I have limited my examples to just the 3 common elements in each of these groups. Now, also in the last lesson, we said that group 1 elements or group 1 metals are able to lose 1 electrons, and that's why we say they are in group 1, because they have 1 electron in their outermost shell. All of them, lithium has 1 electron in the outermost shell, sodium has 1 electron. That's the reason they are in the same group, and they are able to lose this 1 electron to form ions. The same thing goes for the group 2 element. They have 2 electrons in their outermost shell, and they are able to lose these electrons to form ions. So you remember we said group 1 elements, all of them will form a charge of +1. And group 2 elements will form a charge of +2. Why? They are losing 1 electron for group 1 and losing 2 electrons for group 2. Now, how are we going to define ionic bonding? We define ionic bonding as a form of bonding that exists between metals, right? Metals and non-metals. Metals and non-metals. So ionic bond is a form of bond. That's the first thing you should keep in mind, that exists between metals and non-metal. And what are these type of metals? Group 1 metal or group 2 metals. Now, let's look at the other examples of the non-metals. Now, in this case, we are also going to look at the specific non-metals that can react or form a bond with each of these groups. With group 1 element, they will undergo bonding with group 7 element. And group 2 elements are able to undergo bonding with group 6, usually, or they may also undergo with group 7. So now you see that it's becoming more easier, right? And in group 7 is where we have fluorine, chlorine, bromine, right? And in group 6 is where you will find oxygen and silicon. Usually our major attention, our focus will be on oxygen. So now, why is it easy for group 1 element to react with group 7? Can you answer that? Again, it's almost the same method or the same way we answer this question, that group 7 elements have 7 electrons in their outermost shell. So when you look at group 7, they have 7 electrons in their outermost shell, and they need 1 extra electron to become stable, which group 1 elements can give to them. Okay, group 6 element, of course, like oxygen, they have 6 electrons in the outermost shell, and they need 2 more electrons to become stable, which group 2 elements can give to them. So now we said that the first thing about ionic bonding is it is between metals and non-metals, and you have seen the examples of the metals and the non-metals that can form ionic bonds. Now, another thing to keep in mind is it involves the complete transfer of electrons. So complete transfer of electrons. So it's also another key word is it involves transfer of electrons. Transfer of electrons. Where is the electrons being transferred from? The electron is being transferred from the metals to the non-metals. So you remember in the last lesson, we said that metals will lose their electron to become positive ions. So they lose those electrons to the non-metals and they will form positive ions. So now you understand a simple theory, or you have a good understanding of the definition. So I will just recap the definition again, that when metals react with non-metals, electrons are transferred from the metal atoms to the non-metal atoms. And the metal atoms will lose this electron to become positively charged by transferring these electrons to the non-metals, so that you see the metal have just one electrons in their outermost shell, and when they lose this, this shell will be gone, and then they will have a complete shell that has a stable or a full electronic structure. So they will have a shell that has 8 electrons that is filled up in that shell. Okay, so now that you have an understanding of what ionic bonding is, now let's move on to see how do we represent ionic bonding. So now we are here. We want to learn how to represent ionic bonds. It's something you must have seen me using so far. And to represent ionic bond, we use the dots and cross diagram. Dots and cross diagram. Okay, use the dot and cross diagrams. Now, this is very easy. It's just a way to differentiate one atom from the other. Now, let's look at a simple illustration. Imagine potassium. Remember, potassium has 19 electrons. And in the outermost shell, potassium is a group 1 metal, right? So that means in the outermost shell, potassium will have 1 electron. Now, what you have to do is, okay, if we have to represent this, we want to see how potassium will lose its electron to a non-metal. So we're going to see the bond between potassium, which is the symbol is K, and chlorine, which symbol is Cl. Potassium has 1 electron in the outermost shell, remember, and chlorine has 7 electrons in the outermost shell. Bonding cannot exist between potassium and oxygen, right? If it's going to take just if we have to do that, we're going to see it later on. If that must happen, we're going to see this condition in which that must take place. But let's keep on now between potassium and chlorine. Now, I will decide to use cross. I will use cross for metals. And this is the symbol for the cross. And then I will use dots for the non-metals. Now, what do we do? You're going to just let's draw the shell electronic configuration for potassium. Remember, the smallest shell will take just maximum of 2 electrons. And then every other shell after that can take up to a maximum of 8 electrons. So, and remember, potassium has 19 electrons. So now that is 10 already. So I will draw another shell. another shell, then can take more, 8. Okay, and potassium has one more shell. It has one more shell, and that shell just has, now mind my diagram is a little bit wobbly. Now that shell has one electron in the outermost shell. Now we're going to do the same thing for the chlorine. Okay, so remember I said we're using dots. So you want to differentiate the atom. That's why we're using dot. So the smallest shell will take maximum of 2 electrons, and then the next shell can take up to maximum of 8. So 2, 2, 2, 2, and that's 8. And the next shell, that makes it how many? That's 17. Good. When we draw the 7th one, so now this will take the 7th, 1, 2, 3, 4, 5, 6, and 7. So now this is what we call the dot and cross diagram. So they want to undergo bonding, and by saying they are undergoing bonding, we're saying that potassium is willing to transfer the single electron to chlorine. So potassium has one electron in the outermost shell. It's a metal, and it's going to transfer that electron to chlorine. And if it does, it means this one electron in the outermost shell is coming here, right? So in the end, we are going to have, after they reacted together, we're going to have a new diagram, right? A new diagram. Remember, when a metal loses electron, it becomes an ion. So the number of shells for potassium will now reduce. It's going to reduce from what it was before. It has, so the next shell, we also take 8, right? 1, 2, 3, 4, 5, 6, 7, 8. And we are also going to have the last shell, right? So the last shell, we also take 8 electron. Okay. Now, we are going to use a square bracket to show that. And then we put the charge. Remember, this charge is to tell us that it has lost 1 electron. Potassium should have how many shells? It has how many shells? 1, 2, 3, 4. But now potassium is having 1, 2, 3 because it has lost 1 electron. The number of shells in the chlorine will still be the same, right? The number of shells still remains the same for chlorine, and the atoms 2, and this is 8. Okay, and then we have the last shell. Okay, which is also going to be 8. Now, in this case, instead of a dot, we're going to represent the 8th one with a cross because the electron is coming from potassium. So this is to show that the electron is coming from another atom and is being added to that element. So we are also going to draw the square and show the charge as negative to show that chlorine has gained an extra electron. Now, that is how we represent ionic bonding. That is how we represent ionic bonding. We use dot and cross diagram. And the reason why we use dot and cross diagram is to show what happened or what happens during ionic bonding, and to differentiate the electrons in one type of atom to the other. Okay, and then I have given you an example with chlorine and potassium. So you can just pick any of the elements in the periodic table. Look at, since you now know the element from group 1, you can do 4. Can you draw that of lithium and chlorine? You can also do that of sodium and chlorine. You can also do that of, if you like, you can also do now that of magnesium, and yeah, you can do magnesium and oxygen. And we can also see later on, which is going to be the next thing I'm going to show you, is we're going to see something like magnesium and chlorine, how these kind of bonds can be formed. Now, let's look at an example with magnesium and oxygen. Now, don't just think that we are just trying to explain a theory that doesn't exist. No. Now, in this example, for example, you're going to see the illustration of magnesium and oxygen, and that is an illustration of a situation where magnesium is bound in air. When magnesium, when we talk about combustion means when you are burning something in the presence of oxygen. So the kind of bonding that exists between magnesium and oxygen is during their combustion reaction, where magnesium is burnt, right? When magnesium is burnt, it forms magnesium oxide. Now, what we are trying to say is magnesium oxide is an ionic bond. And we want to look at how that can be represented using the dots and cross diagram. Now, remember we said that magnesium is a group 2 metal, right? And 2 atoms of magnesium is going to react with 1 molecule of oxygens. Now, I'm saying some technical terms, which I will say you shouldn't bother about at the moment. I will let you know when to bother about them. So what we want to see is magnesium is in group 2 of the periodic table, and it has 2 electrons in the outermost shell. So if I'm going to draw the shell for magnesium, so this is magnesium, and magnesium, I'm saying it has 2. Now, I could actually just draw the outermost shell, but I'm just going through this to be sure that everyone would be able to do what I'm doing. So if you are already happy with all of these parts, you can just move the video forward so you can go to where may be of interest to you. All right, so this is all that we have for magnesium. Magnesium has 12 electrons. So we can draw one more shell, just one more shell to show the 12 electrons. So we have one here, one here. So these are the 2 electrons in the outermost shell. Now, oxygen is in group 6. That means it has 6 electrons in the outermost shell. Remember, oxygen is in group 6, so it's reacting with oxygen. Oxygen is a group 6 atom, and I'm going to use a dot to show that. Okay, group 6. So it has 6 electrons in the outermost shell, and the atomic number is 8. So this is 8. So these are the 6 electrons in the outermost shell. So what happens? Now, one oxygen, which is what we have here, is going to take the 2 electrons coming from magnesium this way. See that? The 2 electrons coming from magnesium are going to the oxygen. Now, what will happen is that magnesium will become more stable, right? And oxygen also will become more stable, so that when we draw the same structure again, you're going to have something that looks like this. Just draw the shell. Okay, so we have our magnesium and 2 electrons inside. Now 8 electrons in the outermost shell. And remember, we have to show now that it has lost 2 electrons, and we are going to write that as 2 plus. And then the next thing is to do the same thing for oxygen. Oxygen, right? Oxygen, and we're going to do the same thing for oxygen, which is we draw that. Now remember, 2 electrons came in. So this is oxygen inside. 2 electrons from magnesium. Right. So the blue one. And then we show that as -2. Now, this is all the way. What we're trying to do so far is just to learn how to represent ionic compound using the dot and cross diagram. Of course, there are other methods for us to represent what happens during an ionic bond. We have other methods apart from that, but at this we can have the 3D or 2D model where you can show what is going on, but our focus is not on that at this moment. So what we just want to focus on is how to represent it using the dot and cross diagram. Now, another thing to keep in mind is that when nonmetals loses electron, right, their names will change. When nonmetals, when they gain electron, for example, oxygen, when oxygen gains electron, the name will change from oxygen to IDE. That is the ending name, which is this 3 ending name here. The ending name will change. So we're not going to call it oxygen any longer. We're going to call it oxide. So whenever you hear oxide, is to tell you that this element, oxygen, has gained electrons. So for example, when I say magnesium oxide, the oxide there is to tell you that oxygen has gained electron and is now oxide. So you can imagine when we have sodium, we don't call it sodium chlorine, no, we call it sodium chloride. Why are we calling it chloride? It's because chlorine has gained an electron. Remember, the metal will retain their own name. They are the one losing the electrons, so they always retain their names. So this will be chlorine. So it's sodium chloride. So when you hear something like chloride, chloride is an ion. So it's going to be written as Cl-. Okay. But if you want to talk about the metal, we'll say sodium ion, right? We have to put the ion for us to know. But for the non-metals, the name will just be replaced. The ending name will be replaced with IED. So you see, from chlorine, we return to chloride, oxide, right? So that's on and on it goes. Fluoride. Iodine will be iodide. So that's the way the names will change. So if you have a metal reacting with a non-metal, the metal is transferring the electron to the non-metal, and the names of the non-metal is going to change. Okay, so that's how that works. Now, what is left for us to do is to learn about the structure of ionic compound. The structure of ionic compound. Now, ionic compound have a structure we call giant ionic lattice. Okay, so they have a structure we call the giant ionic lattice. Giant ionic lattice. So that's the structures formed by an ionic compound. And the lattice is a closely packed, whenever you hear the word lattice, is a closely packed regular arrangement. Okay, something like, when something is closely arranged in a regular pattern, right? Seeing something like this, we call this lattice, right? Why is it a lattice? Because it is closely packed and it is arranged in a regular pattern. So the structure, when we, what we are doing is not the structure of the bonding, but when you want to observe the structure of the bonding in a powerful lab, what you see is you're going to see the bonds arranged in what we call a giant ionic lattice. And there are very strong electrostatic force of attraction between these atoms. Now, remember something which I like to say here is that if you have a positive and a negative charge, you remember that when charges are not the same, they will attract each other. Okay, so a positive charge is attracted to a negative charge, and the force of attraction that is keeping both of these charges together is what we call electrostatic force. So in between the molecules of the ionic compound, so if you have something like sodium, and you imagine these are the molecules of sodium and that of chlorine coming together, they are being held together by what a type of force we call electrostatic force, which is a very strong force of attraction. It's a very strong of attraction that is acting in all directions. So it keeps, it's not just that, let's just imagine this is one of the molecules. The force is holding them together in this direction, in this direction, in this, it's holding the atoms together in every direction, that it is very difficult. That's what we're saying here. It is very difficult for you to break the bond. Okay, when I say breaking bond, you can just picture something like your ice cube. If we have we have water that has been frozen, and that's solid. Water in the solid form, we call it ice. And for you to melt ice is actually easy, right? You just have to apply it, and the molecules will be broken and the solid will turn to liquid. However, in the case of ionic compounds, what we are trying to say is you cannot just apply it and break them apart. No, because the electrostatic force of attraction is a very strong force that holds oppositely charged particles together, and this force acts in all directions. So it acts in all directions. So this is the major thing you have to keep in mind about the structure of ionic compound. Now, later on, we're going to see that because of this force and the kind of structure they have, it made the compound to have high melting and boiling points. They have high melting and boiling points because they are held together by strong ionic bond, and they have a very strong electrostatic force that is holding their molecules together. So they have high melting and boiling point. It's not easy for you to break those bonds. Okay. So, and that's we talking about the properties of ionic compound. They do not conduct electricity when solid. Because now the ions cannot move, so they have to be in solution. You have to put them in solution before they can conduct electricity, and they have high melting point and boiling point, said that, and they have giant structure that we call giant ionic lattice. So again, this will bring me to the end of the lesson on ionic bonding. I hope you found this very helpful. Again, you can look at all the different exercises you have on this topic. Remember to leave your questions in the comments area, and then I will see you in the next lesson. Bye.